Now, today we are again concentrating on multi-objective decision making problem, but today's lecture will be on multi-attribute decision making problem. Now, where is the difference between multi-objective decision making and multi-attribute decision making? That part I am going to tell you, but one thing you have seen, if I define a multi-objective decision making, there is a we use the term as a multi-criteria decision making, because you have seen in my previous class that there were several criteria together and we were optimizing all the criteria simultaneously. That is why mathematically if we say that, we will say maximize or minimize f1x, f2x up to fkx subject to gkx less than is equal to 0. What else we have seen that we were considering f1 criteria, f2 criteria up to fk. There are k criterion together and there is a set of constraint g I all are within us. We call this kind of problem as a multi-criteria decision making problem, but multi-criteria decision making problem will take the name as multi-objective decision making problem when we are having the feasible space with infinite number of options. But if in the feasible space we are having the finite number of options, we call the multi-criteria decision making problem as multi-attribute decision making problem. And multi-criteria decision making problem in general we are naming it as MCDM. And my previous lecture was on MODM, multi-objective decision making, and today's lecture is on multi-attribute decision making, MADM. That is why today's we are referring to those kind of optimization problems where we are having several criteria together, several objective functions together, but the constraint space has been prepared in such a way that we are having only the finite number of alternatives. Okay. Now, if I just summarize what are the characteristic of a multi-criteria decision making problem, there we will say that we will have multi-objective or multi-attribute there, and all the criteria are conflicting in nature, and there is another very much important thing is that all criteria are incommensurable in nature. Incommensurable means they are being measured in different units. If one objective function is being measured with meter, another objective function can be with hours, it can be with the kg, okay, and we are comparing all objective function which are incommensurable in nature in different units, all together we are comparing, okay. That is the beauty of multi-criteria decision making, and generally we are using the multi-attribute decision making problem for the case where we are dealing about the selection process. We are organizing one interview where there are candidates, 20 candidates are there, and we have to rank all the candidates there. There we are dealing about the multi-attribute decision making problem. That is overall as a multi-criteria decision making. Why we are calling it as a multi-attribute decision making problem? Because you see, whenever we are selecting a candidate for certain position for a job in one organization, we are looking at few attributes. First of all, what is the academic qualification of the candidate? What is the IQ level of the candidate? What is the presence of mind of that person? And what is the whether he or she is having the job experience, this kind of job experience or not. If they have the job experience, what kind of, whether that experience matches with the present requirement or not, all this attribute we are considering together, okay. That is why multi-attribute decision making problem is very much popular, and without knowing the multi-attribute MADM, we are practicing every day, because we are organizing interviews, we are organizing selection process, we are selecting a proposal from a group of project proposal. Without knowing that, we fix few criteria, and with respect to those criteria we are selecting the object, we are ranking the persons, we are ranking the project proposal. Okay? That is why this is coming under the arena of MADM, multi attribute decision making problem. I will tell you today one process how to handle this situation very methodically. Now, if I just summarize, if I just say about the Pareto optimality, I would say that there is a function. This is in the domain of the function, there are two functions, two criteria, we are optimizing both, we are minimizing both f1 and f2, and this is the feasible space where infinite number of alternatives are there. Then within the, if I just consider the edge of this feasible space from A to B, that is the Pareto optimal frontier, rather the Pareto optimal points, because if I just, if all the points are equally accepted to me, that is why mathematically it is being termed as a point x naught is said to be Pareto optimal if there does not exist any other x such that if I x less than equal to f j x, f I x naught for I is equal to 1 to k, and for at least one j is in between 1 to k, the f j x is lesser than, it maintains the less than dominant structure between x and x naught of the same function. Okay? It means that at least in one point, one functional value is less than the other functional value for the minimization case, but all other points it may happen that all are equal. Okay? That means I cannot say this one is better than the other one. I won't get any such point where this structure will be maintained. That is why I would say that if f1 is greater at this point, then f2 is lower than the other point. Okay? That is why I have to compromise, I have to give up some value of one objective function in lieu of the increase of another objective function. That is the basic idea of Pareto optimality, basic idea of the non-dominant point, non-dominated points. We call it as the efficient points or Pareto optimal points or non-dominated points. Okay? With this basic idea, I am just explaining to you today one methodology that is very popular method, analytical hierarchy process, has been invented by Professor Shetty in around 1980, and that time it has been invented and very popular. You can use it for any selection process, analytical hierarchy process. I am going to explain few calculations how to handle that situation. Now, you see that as I said, the classification can be done in this way. Multi-criteria decision making is being classified into two parts, one is MADM and another one is MODM. MADM works on the situation where number of alternatives are finite, feasible space provides finite number of alternatives, and MODM is being applied when we are having that infinite number of alternatives. Okay. Now, we are considering one of the example. A company is selecting a new location to expand its business. There are three options for them. Now, company wants to use analytical hierarchy process for this activity. Now, the company has four criteria for decision. One is the property price, distance from suppliers, the quality of labor pool and the cost of labor. That is very obvious situation. Now, with respect to these four criteria, rather four attributes, we have to judge which location is the best location, and he is having certain information. Without information we cannot take any decision. Always in decision making situation we have to collect information about the situation more. If we can collect the information, then only we go for the mathematical model. As I said, there are four steps: information collection, quantification of information, mathematical model building, then the decision comes. That is why here the information has been given to us. We are here to build the mathematical model and solution. Now, what kind of information has been given here? You see, all the time we are very much preferred to give the preference of certain thing with respect to a scale. Okay? We are saying that you must have been experienced in several places to give your feedback within a scale of 5. If 0 is scale of 5, 1 to 5, if 1 is there, that means poor service, 5 is there, excellent service, 4 is there, good, very good service, 3 is there, good service, and 2 is there, satisfactory. You must have been come across to give the feedback this kind of scale. It could be from 1 to 5, it could be 1 to 9, 1 to 10, 1 to 20. That depends how organizers are providing you the information. Okay, how they are asking the feedback from you. Okay, that is why here also the same case. There only we can apply the analytical hierarchy process. There is a scale from 1 to 9, from poor to excellent. Now, within that scale, and you are asked to give your opinion regarding 3 locations and with respect to 4 criteria. Okay, that is the idea. Let me first explain you what is the scale we are considering. That is the ordinal ranking is there from 1 to 9. I will tell you the description of the scale. Just look at the scale structure. One is, if we just give one value, if you give one value, that means you are giving, first of all I have to say that you have to give your opinion about 3 locations. You are experienced, you have been asked to give your opinion. Okay? Now, you are giving opinion whether location A is better than location B or not. If with respect to cost of labor, if you feel with respect to cost of labor both the locations are equally important to you, then you will give 1. Okay? Because you will give one matrix with respect to A and C, A and B, B and C, B and A. With that, just you will prepare one matrix with respect to one of the criteria, cost of labor, property, the price of the property, that is another criteria. If 1 you are giving, equally important, 3 you are giving, that means moderately important, 5 strongly important, 7 very strongly important, 9 extreme important, and intermediate values are given, that means you are flexible to give in intermediate value. If you are not comfortable to say, if you are not very much willing to say that one is strongly important the other, okay, then you won't give 5. If you are not even willing to give that one option is moderately important than the other option, then better not to give 3. You are given another option, that is 4. You can give the 4 value for that. Okay, that way the intermediate values are given. That has been provided, the whole scale has been provided by Professor Shetty only. He has said just you ask everybody to give the option from 1 to 9, and 1 means this, 9 means this, intermediate value means this. Okay? And there is another option has been given, the reciprocal. For example, A is strongly preferred than B. Give the option as 5. With respect to property price, the location A is strongly important than location B. Give 5. But if I say, then what about the B with respect to A? Then it will be 1 by 5. Okay? That way you give your preference within the scale. Now, if I just draw for with respect to 4 criteria, there one criteria was property price, another criteria were there cost of labor, no, quality of labor, distance from supplier and cost of labor. Okay? Now, if I just do it, you see there are 3 options A, B and C, because we have to take a decision that which location is preferred than the other. Now, we are going for are we going for a single option, that is another question, we do not know. This is only given to us, there are 3 locations. It may happen that we cannot select one location at a time, okay, because as you know there are 4 criteria, 4 are conflicting criteria. If the property price is very low, do not expect that quality of labor will be very high. It may happen the property of the price is very high, that means that is near to any city, then cost of labor will increase. Okay, you can't expect that you will, with a lower cost of labor, you will get a place, a location where the place is very good, very near to the city, very near to the suppliers. Okay, that is why always there is a trade off. If you compromise with property quality, then you have to you will get better value for another objective function. If you are compromising for all together, you will get a good option. That is why again the situation is something where we are going for the Pareto optimal solution, we are going for the non-dominated solution, we are going for the efficient solution. That means that we have to select, maybe the situation may come that we have to select both the locations A and C together. I will say that both A and C both are equally preferable to me. It may happen. Let me see, we do not know, this is the only information given to us. With respect to property price, you see that, let me explain the matrix now. With respect to property price, it has been said that A is 3. 3 means what? 3 means moderately important than B. Okay? And A and C, if we just compare, what is given there? That 2, that means not equally important, not moderate important, in between. It is given that A is preferred to C, preferred but not moderate, not equal, better than that. That is why A is preferred to C. Look at C with respect to A, since A with respect to C is 2, then C with respect to A will be 1 by 2. That way just you see A with respect to A1, B with respect to B1, C with respect to C1, but all other given accordingly, alright. Similarly, for the distance from suppliers, you are giving your option, you are experienced person. Actually what we do for doing such thing, we are collecting, we are doing the market survey, is it not? We are doing the market survey and we are looking at that from the experienced person we collect information through the questionnaire. That is the common practice we do, okay? And that is why through the questionnaire you are circulating the questionnaire to different experts and you are collecting information. They are giving their opinion just in the scale. Now, you are there for quantification of information. After collection of information, in the quantification stage you are making all the matrices, okay? That is the task of yours, because that is the need of HP. Everything you have to do within the scale of 1 to 9, then only you very nicely you can apply the HP there. We will prepare this matrix. Once we will prepare this matrix, with respect to every matrix, we will prepare a dominance vector, that is called the priority vector. That is why our task in the next, that with respect to price we will rank ABC, with respect to distance we will rank ABC, with respect to cost of labor, quality of labor, we will just do ABC. But you see, it may happen that to me quality of labor is more important for my business than the property price. It may happen, okay? All the criteria are not equally all are not equally important to me, it may happen, okay? Because I am doing such a business where quality of labor is very much important, because if they are not knowledgeable enough, my product will not be up to that levels, up to that standard. That is why I can compromise in that sense. I may locate my new business house maybe far from city with less property price or more property price nearer to the city, but I cannot compromise with the cost quality of labor. It may happen. That is why within the criteria itself we are having the preference structure. Again you can ask to the people, or you can ask yourself, just you give your opinion in the scale of 1 to 9, the standard scale I have provided to you, that also quite possible. Okay? That is why there also another option is left for us to give the preference with respect within the criteria itself. Okay? Now, first, as I said, for 4 individual matrices we will prepare the priority vector. Priority vector nothing but we are making the ranking, ordinal ranking, cardinal ranking for 3 locations A, B, C. We are going for the cardinal ranking rather with respect to this information in the next. Okay? Now, you see what we have to do for that. For price, let me take the first table price. Alright. We are having the table 1, 3, 2, 1 by 3, 1, 1 by 5, half, 5, 1. What we will do? First we will make the sum of the columns. 1 plus 1 by 3 plus 1 by 2, it is equal to 11 by 6. 3 plus 1 plus 5 by, this is 9. First we will sum, add up all values in each column and put it at the bottom. Once we are getting it, after that we will divide individual element of that column with respect to the column sum. That means we are normalizing. Okay? That way we are normalizing. Just we are doing that thing. Next, the values in each column are divided by the corresponding column sum. After doing that, we will take the row average of the corresponding rows and we will get the priority vector. Let me show you how exactly we have done. You see the previous table 1 by 11 by 6, it will become 6 by 11. 1 by 3 divided by 11 by 6, it will become 2 by 11. 1 by 2 divided by 11 by 6, it will become 3 by 11. Just you see we have done so. 6 by 11, 2 by 11, 3 by 11, just make it as a, you can make it as decimal because we are doing some kind of normalization. That is why we are putting the priority vector, we are calculating the priority vector from 0 to 1. We want to put the values from 0 to 1. Individual elements are coming within 0 to 1. Just you see, though we were having 9, 7, 5, all we are bringing together from 0 to 1. This is a kind of normalization we are doing. After doing that, we are having individual element value for individual row, okay, and we are taking the row average. Once we are getting the row average, you see sum of row values are coming as 1, and from the individual thing it is very much clear for us with respect to property price. You see C is preferable. With respect to property price, B is preferred than A. That is why one kind of preference we are getting with respect to one of the criteria. But if I ask you that if I just include the cost of labor here, the situation may differ. It may not happen that ABC will be the order of increasing. Here the values are in the increasing order. Alright. This is a priority vector we call it as, but it's called it as a preference structure with respect to price for A, B and C. Same thing we have just summarized in this table. Alright. Now, similarly for individual cases we can have for price this one, for distance we can have the priority vector, for labor this is the priority vector, for the wage this is the priority vector. You now compare. For price you see, if I just see the price, it is, this is 0.5 for the price, not 5. Okay. Some calculation, just you do the calculations and you will see the values. 0.5? 0.5. Okay. Now, if this is the case, you see this structure is not maintained here, because here the maximum value is in C with respect to distance, but here the maximum value is B with respect to wage. All right. Now, as I said, these are the priority vectors with respect to individual objective functions. Now, for each criteria again we can have the preference structure with respect to price, distance, labor and wages. We can have different structure here also. I can put a scale, I can use a scale from 1 to 9 given by Shetty, and within that we can have the structure, preference structure is like that. That means distance and labor, distance is strongly preferred than the quality of labor that has been given. Okay? Strongly preferred. Oh, sorry, strongly preferred. Similarly, distance is less strongly preferred than the wages. All right. In this way, we can have the matrix like this. Here also you could understand, as we have done for price, distance, labor and wage, for we can do again here the priority vector for all criteria, that is also quite possible. Now, if this is so, then we can have another matrix for price, labor, price, distance, labor and wage. This is the priority vector. That means, we are doing some kind of normalization so that the sum is 1 and we are doing that. If I just put all together, this is the situation for us. Criteria in one side, in other side location, with respect to location, individual. Now, this is the process, analytical hierarchy process. You can practice it, you can do it for your day to day selection process. This is very popular method and very easy to do this kind of methodology, but one restriction is that if we do not have the information of this kind, where the people are giving their opinion with respect to a certain scale from 1 to 9, this methodology is not applicable. We are having several other methodologies on multi-attribute decision making problem, those methodologies will be applicable. Now, after that we are making the score of individual location. How we will make the score? That is very simple. We will take this into the criteria plus with respect to location A plus this into the next point lever 0.1790 into 0.0860, 0.1561 into this one. If we just make, we can take the location A score is coming 0.3091, we can declare. Now, we do the calculation for B and C. What we could see, the location C is dominating, but what about location A and B? Both are in the same level, no one is better than the other one, both are equally acceptable to us. That is why if we just make the rank, we can declare that C is the best choice, Pareto optimal, I would say in this case, because we can say even after this we can say C is the optimal solution for us, because we do not have two options together, but in the next level you see A and B both are equally acceptable to me. It could happen that C and A are equally accepted to us. Okay? Then we will say both are non-dominated to each other, both are Pareto optimal to each other. But here in this case we can say C is the best choice. But you see, after doing so much of calculations were very simple, just plus minus, nothing else, and the multiplication, division, nothing else we have used here, no mathematical rigorous mathematics we did not do. That is why this process can be applied anywhere and you should practice it. And I can say, after using the analytical hierarchy process, in short HP, we have reached to this situation. But all the time the situation is not given in this way. People are preferring the information to give in a different manner. For selection process, it may happen that what is the percentage of academic record in class 10, we are putting 70%, some other person 71%. What about higher secondary, we are giving a mark. What about his presence of mind, that we are putting in a scale. What is the smartness of that person? I am putting some mark there out of 0 to 100. That means all the information we may give in a table, in a matrix, where all are incommensurable in nature, all are being measured in different units. Here you must have seen all are being measured in the same unit from 1 to 9, there was no variation. That is why so easily we did the calculation, but this is not the case all the time. We are putting the summary of the candidates in one sheet with respect to different criteria, and the data is in the different scales. In that case, analytical hierarchy process is not applicable. There is another well known process is there, that is called the TOPSIS. In full it is being named as the technique for order preference by similarity to ideal solution. There the process is being done in a different way, and if you are interested, you can learn more about it regarding TOPSIS, but HP, TOPSIS, Prometheus, these are very much well known process for multi attribute decision making area, and with that I am concluding the whole. Thank you very much.